Hello folks, my name is Dmitry and I am grateful to Supabase who invited me today to tell you about some open source stuff I do. Most of my projects are around web APIs, where I try various ways to make them more reliable. The first project is Schematicis. It's a tool for randomized testing of web APIs. It reads API schemas in the OpenAPI or GraphQL formats and generates thousands of test scenarios that will make sure your application works as expected. It runs positive and negative test scenarios where each endpoint could be tested in isolation or statefully. It checks whether some request crashes your application, corrupts the database, or just makes your application hang forever. It checks that all responses are conforming to their specifications and that all explicit examples are up to date. It's a Python library that you can easily extend yourself by tweaking the data generation part or how it checks the responses. Your application could be written in any language. The only thing you need is at least a basic API schema. Another library I work on is Json Schema. It's a Rust crate that performs JSON schema validation. Often it performs it orders of magnitude faster than other libraries. It has bindings for Python, for Ruby, for Node.js. You can try it yourself. Or if you're a Postgres user, you can try the PG Json Schema extension written by Oliver Rice from Supabase. If you have any questions, feel free to ping me on Twitter. My handle is Stranger6667. Looking forward to hearing from you. Have a nice day.
PG Json Schema is a Postgres extension that provides JSON schema validation for Postgres's built-in JSON types. JSON Schema is a data validation spec that can describe the shape and contents of documents, and the extension exposes two functions for that use. So we can get started here by doing create extension PG Json Schema, which will create the extension and expose these two functions. These two functions have identical call signatures other than the instance type here. We provide them a schema, which is the JSON schema, the spec that we want our instances to conform to, and an instance. If your instance is a JSON type, use the JSON matches schema function, and if it's of JSON-B type, use JSON-B matches schema. This is the simplest way to call the functions created by PG Json Schema, but it's not the most immediately useful. So let's just do this as an example. All right, so our schema here is asserting that the type of the instance is an object, and we can see that that is true in this case. That's a JSON object. We have the same schema in the JSON-B example, but the instance is now not a match. It's an integer instead of an object. So we got true on this first call, and if we run this, we're expecting it to be false, and it is. The more immediately useful application for these functions is in tandem with a check constraint on a table. If you're not familiar, check constraints are a Postgres primitive for validating the contents of rows as they're being inserted into a table. They are expressions that are expected to return true if a row should be accepted and false if it should be rejected with an exception. Here is an example of that. We have a blog post table with two columns, ID, serial, primary key, and a metadata JSON column. This is the one that we're going to be validating. Here is our check constraint, that expression that's expected to return true or false. And JSON matches schema call is right here with the schema embedded directly in and a reference to the metadata column that we want to validate. So what we're validating in this case is that the metadata column is of type object containing the attribute named tags, and that attribute is an array of strings with a maximum length of 16. So let's create this table and do a couple of inserts. Now this one should pass. We have our object with the tags field, and that is an array of strings. So that inserts without issue. Now we have a failing instance. We do have our tags, but it is an array of numbers instead of an array of strings. And when we try and do that insert, we get a explanatory error message, and that gets returned to the user. The underlying implementation of the JSON schema validation is provided by a Rust crate, Json Schema _rs. You can take a look at their docs for a full description of which JSON schema drafts and features are supported. It maps one-to-one with PG-JSON schema. You can get a link to those docs along with a few more examples, usage examples, at github.com/superbase/PG_JSON schema.